quantum breakthrough, exotic matter for interplanetary missions. Imagine a world where computers can withstand the harsh conditions of outer space, thanks to a groundbreaking discovery in quantum physics. Researchers at the University of California, Irvine, have uncovered a new phase of quantum matter that could revolutionize both computing and space exploration. But here's where it gets controversial. This discovery might also challenge some of the fundamental principles of materials science. Updated July 25, 2025, 02:18 p.m. To put this in perspective, quantum phases of matter are not your typical solids, liquids, or gases. These states arise when electrons behave collectively under extreme conditions, leading to properties that defy classical physics. For example, superconductors, which allow electricity to flow without resistance, are a type of quantum matter. Topological insulators, which conduct electricity only on their surfaces, are another fascinating example. It's a new phase of matter, similar to how water can exist as liquid, ice, or vapor, explained Jauregui. We've only ever seen it predicted in theory, but now we've actually measured it. The key to this discovery lies in the unique interaction between electrons and their positively charged counterparts, known as holes. When subjected to ultra-high magnetic fields, these particles pair up and spin in unison, creating a highly stable and luminous fluid of excitons. If we could hold it in our hands, it would glow with a bright, high-frequency light, Jauregui added. Hafnium pentatelluride, the material that enabled this breakthrough, was synthesized by Jinyu Liu, a postdoctoral researcher in Jauregui's lab and the lead author of the study. The team took this material to Los Alamos National Laboratory, where they exposed it to the intense 70 Tesla magnetic fields. As the magnetic field strength increased, the material's electrical conductivity plummeted, marking the transition into this new quantum phase. This discovery is significant because it opens the door to spin-based electronics and quantum devices that could be far more energy efficient, Jauregui noted. Spintronics, a field that focuses on using the spin of electrons rather than their charge to carry information, could benefit greatly from this new material. One of the most promising applications of this quantum matter is in deep space missions. Traditional semiconductors are vulnerable to radiation, which can degrade or even destroy electronic systems. However, this new material remains stable under such conditions, making it ideal for space exploration. If you want computers in space that are going to last, this is one way to make that happen, Jauregui emphasized. As private space companies like SpaceX continue to push the boundaries of human spaceflight, the need for durable electronics has never been more critical. Devices made from hafnium pentatelluride could ensure that spacecraft systems remain operational during long-duration missions to Mars and beyond. While the full potential of this discovery is still being explored, the implications are profound. We don't know yet what possibilities will open as a result, but the future looks very promising, Jauregui concluded. The research was published in the journal Physical Review Letters. About the author. Amir Kolam is a seasoned tech journalist with experience at Exhibit Magazine, Republic World, and PR Newswire. His deep interest in technology and science has driven him to explore and explain the latest innovations and their impact on various industries and the future of humanity. UC Irvine scientists discover new state of quantum matter for better computing in deep space. A groundbreaking discovery from UC Irvine could redefine the future of computing in extreme environments. Scientists have uncovered a previously theoretical quantum state that might revolutionize how we power and protect computers in space. This breakthrough, published in Physical Review Letters, reveals a glowing, spin-based material that resists radiation and could enable self-sustaining systems for deep space missions. But here's where it gets controversial. While the science is clear, the real-world application of this material raises questions about its scalability and long-term reliability. The team led by Professor Louis A. Jauregui observed the phenomenon in hafnium pentatelluride under 70 Tesla magnetic fields, far stronger than typical lab magnets, which forced electrons and holes to align their spins into a novel exciton state. It's like water turning into ice or vapor, Jauregui explains. This is the first time we've seen this phase measured, not just predicted. The material's resistance to radiation is a game changer. Unlike conventional electronics, which degrade in space's harsh environment, this quantum state remains stable. Imagine spacecraft with computers that don't need frequent repairs, a critical advantage for missions like SpaceX's Mars colonization plans. Yet, some may argue whether such a material can be mass-produced at scale, or if its glow, a side effect of its spin-based nature, could pose unforeseen challenges. And this is the part most people miss. The research doesn't just focus on the material itself, but how it could shift the entire paradigm of computing. By using electron spins instead of electrical charge, it opens doors to ultra-low-power devices and quantum technologies. However, the real test will be whether this discovery sparks a new era of innovation, or if skeptics question its practicality. What do you think? Will this material truly transform space computing, or is it just another scientific curiosity? New quantum state could revolutionize space tech. Radiation-proof self-charging computers. Imagine a computer that not only charges itself, but also shrugs off the intense radiation of deep space like it's a minor inconvenience. Sounds like science fiction, right? But it's closer to reality than you might think. Scientists have just uncovered a brand new quantum state of matter that could revolutionize technology as we know it. Meet the spin triplet excitonic insulator, a term that might sound like something out of a sci-fi novel, but it's very real and incredibly promising. Here's the fascinating part. This discovery happened under extreme conditions. A material made of hafnium and tellurium was subjected to a staggering 70 Tesla magnetic field. For context, your fridge magnet is a mere 0.1 Tesla. Under this intense force, the material entered a state where it could no longer conduct electricity, but something far more intriguing emerged. This isn't just another scientific curiosity, it's a potential game changer for how we build computers and other electronic devices. But here's where it gets controversial. Could this new quantum state really lead to radiation-proof, self-charging computers? While the science is solid, the practical applications are still in their infancy. Professor Luis Jauregui, who led the study, compares this new state to water existing as liquid, ice, or vapor. It's a fundamentally new phase of matter, but unlike water, this state glows with a bright, high-frequency light, hinting at its unique properties. The big question is, how soon can we harness this for real-world technology? To understand why this matters, let's break it down. Electronics today rely on semiconductors, which use electrons and their positively charged counterparts, called electron holes. Under specific conditions, these can form something called an exciton, but in this new state, the electron and hole spin in the same direction, a triplet state, as opposed to the traditional singlet state where they spin in opposite directions. This subtle difference could unlock a world of possibilities, like using spin instead of electrical charge to carry signals, making devices far more energy efficient. And this is the part most people miss. This isn't just about faster or smaller computers. It's about creating technology that can survive in the harshest environments, like deep space. Imagine spacecraft equipped with computers that don't fizzle out after a few years of exposure to cosmic radiation. Or think about the energy savings. Spin-based electronics could drastically reduce power consumption, a huge win for sustainability. Of course, there's still a long road ahead. As Jauregui notes, we don't know yet what possibilities will open as a result, but the potential is undeniable. This discovery, published in Physical Review Letters, has already sparked excitement in the scientific community. Now the question is, what do you think? Is this the future of computing, or just another scientific curiosity? Let's debate it in the comments. Your take could be the next big idea.